Hello and welcome to this demonstration of our MEDICI tool developed by the University of Greenwich. The purpose of this tool is to provide a security-aware dynamic offloading decision mechanism for the C4IIoT project. More specifically, the role of this tool is to receive requests pushed to us from anomaly detection models running at the edge when they have low confidence. And upon us receiving this request, we will then dynamically decide using previous execution information of other offloaded tasks and live network information to decide the most suitable place for this task to be offloaded and executed. Within this demonstration, we have one BACS edge node which will be generating and pushing requests to our tool, MEDICI. And then we also have a field gateway BACS model and a cloud model, each of which will be running a intermediate and advanced anomaly detection model, and these will be our two possible offloading destinations in which we can forward or offload tasks to be further processed. Okay, so overall, in this GUI, you can see the core aspects of MEDICI and its handling of inbound requests and decisions being made. Along the bottom here, you can see the 3 core servers that run within our MEDICI program. The first of which on the bottom left here is our request server. The purpose of this server is to listen for inbound requests being generated or pushed to us from BACS edge nodes. So we will read in the inbound request, query our decision maker, again based off our execution history and our live network information, and then offload that inbound task to our destination which we decided. In the bottom middle here, we have our response server. So the purpose of this server is to listen for statistics, in this case execution time and execution confidence, of a task that has been offloaded and executed by the models either located at the field gateway or the cloud. And then this information will then be used to inform future decisions we will then make. And on the bottom right, we have our network server. The network server is responsible for contacting our agent programs or services. In this demonstration, there is an agent located at every valid offloading destination. So there's one for the BACS field gateway and one for the BACS cloud. And every second, it will poll these agents to get the most up-to-date latency information. So this will tell us how long it will take for a task to be offloaded to that destination. And we can then use this information and incorporate it into our decision-making process. So furthermore, just cover this in a bit more detail. So on the right-hand side in the middle here, we have a graph just showing the live network information that is coming in and being collected. Okay, and this shows the previous minute of data that's been coming in. Similarly, in the top right, we have our network history. So these are the latencies being held by MEDICI for the BACS cloud and BACS field gateway models respectively, and obviously how long they're taken to contact and reach. We only keep around 5 or 6 records, so that equates to, in this case, 5 or 6 seconds worth of data. So we're only using live, fresh network data to inform our decision-making process. In the top middle here, we can see our execution history information. So these are the records that have been held within MEDICI for the BACS Cloud and the Field Gateway. And we use this historical execution information of previously offloaded and completed tasks to inform our future decisions. So you can see currently, as it stands, there are 48 records held for the cloud model and 179 records held for the field gateway model. Okay. And so these will equate to as you can see on the top left hand side here, all the requests that have been received by MEDICI. So these are the ones that have been generated by the BACS Edge node, and subsequently have been processed and offloaded to either the field gateway or the cloud models. Okay. The two graphs in the middle left and center are showing the predictions that we are making and passing to our decision maker based on our historic information of previous tasks, and we can see how they're changing over time. The graphs show a time frame of the past 10 minutes. These are updated as new requests are made, because this is when we are making new predictions for that task to inform our decision maker, so we can then decide the suitable offloading destination for it. Okay, so now we will make the edge node push a request to us. Okay, so we can see a new request has just been forwarded, been pushed to MEDICI. So this is a task that had low confidence. So you can see at this top line here, we can see, so this is the start of the request coming in. First of all, we assign it a unique identifier. This is to allow us to track it throughout its life cycle. So when we then send this off, we'll be able to track it and update our execution times and confidence when we hear a response back. So then the next couple of lines show the execution of our MEDICI decision maker taking place. And we can see the output that we received from it. Okay, so within this output, this is the destination it's chosen. So it's chosen to send this to the field gateway. And we can see these are the predicted values that we used in making that decision. So following on from that, we have the task now being actually offloaded to the BACS Field Gateway model to be processed by it. And then we will add a new execution record in preparation for the execution time and confidence to be appended to it when we hear a response back from the Field Gateway model. Furthermore, at the bottom here, we can see what a counter being kept track of for the cloud model. So the purpose of this, MEDICI utilizes dummy tasks to send a dummy request to a model that hasn't been used for a set number of times. Currently, if a model hasn't been used or been offloaded to for 4 times, we will then generate a dummy task to then be sent to that model, so we make sure we've got fresh or more up-to-date execution information for that model, as it could change over time. Okay. So now looking back at our response server, so if we see the ID that was assigned to our task ends in 507, so we're looking in the output, so we can see here that we successfully received a response for our task that was sent to the field gateway, and it was reported back to us with an execution time and confidence, and this was then updated successfully into our execution history. So therefore, if we look into this top range here, we can see that so there's our task at 507, and we can see the task being shown. For clarification, this execution information is only displaying the 5 most recent records for each device respectively. So it's the 5 most recent cloud records and the 5 most recent field gateway records. Going back to our output down here, we can also look for our dummy task. So we can see we offloaded a dummy task with an ID ending in 146 to the BACS Cloud. So again, so we can see along here at the bottom. So we receive the response back from the BACS Cloud, again reporting to us a execution time and execution confidence, which was again successfully updated into our execution history. And so then going back to our execution history at the top middle here, we can again look for the ID ending in 146, and we can see the execution time and that execution confidence being appended in there. Okay, so again, just to reiterate, so the whole purpose of that dummy task is so where the cloud hadn't been selected for a set number of times, we were then able to just re-query that model, so we've got constant up-to-date information, execution information for that model, for that offloading destination. Right. I hope this was clear and helpful and informative, and thank you again for watching.